Hi there, so today we're having a look at lesson 7.4a. We're going to have a look at interior angles in polygons. So our objectives today then to recognise polygons and their features and to discover and find the interior angles of irregular and regular polygons. Before we start, some things we should know already. We should know that the angle properties of all three types of triangles, so that's scalene, isosceles and equilateral. You should also know the angle properties of straight lines and points. So angles on a straight line add to 180 degrees and around a point add up to 360 degrees. And you should also know the total interior angles in a triangle and a quadrilateral. So angles in a triangle add up to 180 degrees and angles in a quadrilateral add up to 360 degrees. Make sure you're happy with those before you move on. If not, you may need to go back and look at one of the previous videos. So today then we're having a look at polygons. So a polygon is a two-dimensional shape made of line segments which enclose a region. So remember, a line segment is a short sort of part of a line. So AB would be a line segment, and we've joined those together to form this region in the middle. Now there are two types of polygons that we're interested in. There's the regular polygon. The regular polygon has equal sides and equal angles. And then there is the irregular polygon. So in an irregular polygon, all of the sides and angles may be different. There are two types of irregular polygon. The first type we call a convex polygon. Okay, so all of the points, all the vertices, these corners, are sort of pointing outwards from the middle. So if you start in the middle, you can see they're all sort of pointing away from the centre. And then we've got this one which we call a concave polygon. So where some of the vertices, so this vertex here for example, is actually pointing inwards, so in towards the centre of the shape. Okay, so two types of irregular, and then our regular one where they're all the same angles and all the same sides. We're going to have a look at both of those types today. Before we start then, we need to check that we know the names of our polygons. So often in questions, they don't tell us the number of sides, they simply tell us the name of the polygon. So some of them you will be familiar with, some of them perhaps not so familiar. So a shape with three sides then we call a triangle, four sides a quadrilateral. Okay, we should know those. Five sides is a pentagon, six is a hexagon. Now 7 is probably a bit less familiar to most people, that's a heptagon. 8 is an octagon, 9 a nonagon, and 10 a decagon. You do need to be able to recognise the names of those shapes from our three-sided to our 10-sided shape. Okay, pause the video, make a note of those now if there are any there you're not sure about. Okay, so now that we know their names, we're going to see if we can figure out the total interior angles inside our polygon. So the interior angles are the angles that are inside the shape. So our triangle here is made up of three interior angles, A, B and C. And the sum of the interior angles of our triangle is 180 degrees. Okay. Well, we now know our triangle is 180 degrees, but what about our quadrilateral? Well, hopefully we know the interior angles of a quadrilateral add up to 360 degrees. But can we show that another way? Can we prove that? So how about then if we divide our quadrilateral into two triangles? Now we already know the angles in a triangle add up to 180 degrees. So A, B and C are 180 degrees. And we've got our second triangle, D, E and F, and they also add up to 180 degrees. We can see now that we've got all of the interior angles of our quadrilateral. So we've got this one here is made up of C and D together, this one here is F, and this one is made up of B and E together. So if we add all of those angles together, 180 plus our 180 gives us 360 degrees. So there are 360 degrees in a quadrilateral. Now that we've used this method to move from a triangle to a quadrilateral, can we use it for any of the other polygons? So we've seen that dividing a quadrilateral divides up into two triangles. So a pentagon can be divided into three triangles. So if we start at one vertex and draw our diagonal lines across, we can see we've got 3 triangles. So that's 180, 180 and another 180. Well, what about our hexagon? How many triangles can we split our hexagon into? So again, let's start at one vertex and go from there. And you can see that we've split it into 4. Now hopefully we can see there's a relationship between the number of sides our shape has and how many triangles we can split it into. So our quadrilateral had 4 sides and we created 2 triangles. Our pentagon had 5 sides and we've got 3. And our hexagon had 6 sides and we've got 4. So remember in maths we're always looking for patterns. How do these numbers relate to each other? Well, the way they relate is that the number of triangles that a polygon can be divided into is always 2 less than the number of sides. Okay, remember anything you see in a green box is worth noting in your maths book because it means it's a key part of the work that we need to remember for later. So, if we had a polygon with n sides, n being any number of sides that we liked, we could divide it into n minus 2 triangles. So if I had a 100-sided shape, that would be 100 minus 2. I could make 98 triangles. A 50-sided shape, 50 minus 2, I could make 48 triangles. So we can easily work out how many triangles we can make. We know that the sum of the interior angles in any triangle is 180. So if we do 180 multiplied by the number of triangles we can make, we will get the total interior angles. So the formula that we use then is that the sum of the interior angles of an n-sided shape is 180 multiplied by n minus 2, the number of sides minus 2. Okay, so 180 times the number of triangles effectively. Pause the video now, make sure you've noted down those key parts from those green rectangles. Alright, so let's see if we can use that rule then. So first of all, we've got a triangle. We can split a triangle into one triangle. One triangle has 180 degrees, so its total interior angles are 180 degrees. Our quadrilateral we could split into 2 triangles, so 2 lots of 180 degrees, so the total interior angles are 360 degrees. Our pentagon we split into 3 triangles, 3 lots of 180 degrees equals 540 degrees. And our hexagon we'd split into 4 triangles, so 4 lots of 180 degrees is 720 degrees. Make a note of those and then using the same method, see if you can find the total interior angles for the rest of the polygons up to 10 sides, so up to a decagon. Pause the video, have a go at that now. Okay, so I put my results into a table just to make it a bit easier. You might want to pause the video and copy yours into a table if that helps you. So for our first one then, we had our triangle. So we said our triangle 180 degrees times 1, so 3 minus 2 means we can make 1 triangle, so 180. Our quadrilateral has 4 sides, 4 minus 2 means we can make 2 triangles, 360. Pentagon 5, 5 minus 2 means we can make 3 triangles, so 3 lots of 180, 540, and so on. So you can check your answers down there. Okay, so now how are we going to use these then to help us with our questions? So here we've got an irregular polygon. Okay, we're asked to find the value of x here, and we've been told all of the other angles inside our shapes. We know all the other interior angles, we just need to find x. To be able to find x, we need to know the total interior angles inside our polygon and then subtract the total of all the angles we know. So our first thing is to check how many sides our polygon has. So 1, 2, 3, 4, 5, 6. So it has 6 sides. A 6-sided shape, 6 take away 2 means 4, means I can split it into 4 triangles. So we do 6 take away 2, which is 4, and 180 times 4 is 720 degrees in total. Once we know the total angles in our shape, we can add up all of the angles we know and take those away from our 720. So if we add all of those up, they come to 460. 720 minus 460 means that our x is 260 degrees. Okay, make sure you're happy with that example before you move on. All right, so we've got three different irregular polygons there. So in the first one you need to find angle x, the second one angle b, and the third one angle x again. Make sure you check how many sides it's got first, find the total interior angles, and then subtract the other angles away to find yours. Pause the video, have a go at that now. Okay, let's have a look at the solutions for those then. So starting over here, we had 6 sides, so we've done 180 multiplied by 6 minus 2, which is 4, so 180 times 4, because I could split into 4 triangles, gives me 720 degrees in our hexagon. 720 minus all of the other angles added together, which came to 580, means that angle x is 140 degrees. Okay, this one at the top then, we've got 1, 2, 3, 4, 5, 6. So again, another hexagon. Again, if I want to split it into triangles, I could split it into 4 triangles. So that's going to give us 180 times 4, which is 720 degrees. Add up all of the angles that I know, take it from 720, and that leaves us with 260 degrees for B. And finally the last one then, 1, 2, 3, 4, 5 sides this time. So again, if I want to check, I can split that up into 3 triangles. 3 times 180 is 540 degrees. Add up all the angles I know, that comes to 300. 540 take away 300 means that x is 240 degrees. Check that you're happy with how we've worked those out. Don't forget, it's important to check your answer matches the diagram as well. So here we can see we've got an obtuse angle, our answer is obtuse, a reflex angle, we have a reflex answer, another reflex angle, we have another reflex answer there. So do use that knowledge about the sizes and names of angles to check that your answers are accurate. Okay, we're now going to have a look then at our regular polygons. So the difference between our irregular and our regular is that our regular polygons, all the sides are the same length and all of the angles are the same. So that fact of knowing that all the angles are the same is useful, because it means if we know the total interior angles, we can work out the interior angles for each of the different vertices. So you'll see that in my table I've changed the names slightly. We have some slightly different names when we have our regular polygons. So instead of just a triangle where all of the angles are the same is called an equilateral triangle. Our quadrilateral, a quadrilateral where all of the angles and all of the sides are the same, we would call a square. And you'll notice that in front of all of the others we've just used this word regular. So regular tells us that all the sides and all the angles in this shape are the same. Now that's really important, because as we saw with the irregular ones, all of the angles were different, whereas in these we know they're all going to be the same. So if we know that the total interior angles in our triangle are 180 and that they're all going to be the same, then we can divide that by 3, and it tells us that each angle is 60. So remember, they've all got to be the same, so we can divide by how many there are. There are 3 vertices in this shape, 60 degrees each. For our square then, so 360 degrees in a quadrilateral divided by 4 means each one is 90 degrees. Our pentagon, 540 divided by 5 is 108 degrees. Our regular hexagon, the total was 720, so we can divide it by 6. So each one is 120 degrees. Our heptagon, again, our heptagon is a little bit odd. It does give us a decimal answer, so I've rounded it to 1 decimal place. Our octagon, 1080 divided by 8 means every vertices is 135 degrees. So all the vertices are identical. And then the same with our nonagon and our decagon. So by taking the total interior angles and dividing it by the number of sides, we can find a single interior angle of a regular polygon. So a hint at the bottom then, try to memorise the total interior angles for a pentagon, hexagon, octagon, as they are the ones most commonly used. So we should already know our triangle and our quadrilateral pretty well. Our pentagon, hexagon and octagon are the ones they use a lot in exams, not so often using heptagons, nonagons and decagons. But make sure you've got all of those angles written down somewhere nice and clearly so you can use them when you're looking back at your notes and doing your revision. Okay, finally then, a bit of a memory test. So with this, you need to pause the video, look at the screen for a couple of minutes, turn the screen off, and then try to redraw this slide into your maths book or onto a piece of paper. Turn your screen back on and see how much of it you've remembered. Okay, so those are our key key polygons that we need to know with their total interior angles in them. So pause the video, see how much you can remember. Okay, well, thank you for working through that with me today. Next lesson, we will be having a look at exterior angles in polygons. So click the link when you're ready to move on.